Okay, so we're going to do the magnitude, which the magnitude is where we do the square root. So that's what we've been doing for a long time, where we do a squared plus b squared under the square root. That's our magnitude. Um, in the dot product, we can actually use the dot product instead of finding magnitude to basically get the magnitude. So there's two different ways now to get your magnitude. And here are those equations. So if you do a vector dot itself, okay, so for example, b dot b, it's the same thing as finding the magnitude, okay, and squaring it. So then the magnitude, this is one that you need to focus on. Okay, the magnitude is the square root of the dot product. And I think from yesterday we kind of found that dot product is pretty easy. So it's probably easier to do that instead of doing this. They're both fairly easy. But I think dot product tends to be a little bit easier, so we can use that instead. So let's do number 9 together. Okay? We're going to do the dot product. Now remember, usually we have the dot product with two vectors, but we're dotting itself. So what I like to do is I like to just rewrite the vector, so then it's easy to see what I'm going to do the dot product of. So we're going to do r dot r. Okay, and if you remember dot product from yesterday, you take the first number and the first number of the second, and you multiply them. So 10 times 10. Plus, and then you'll do the second numbers, 24 times 24. And you put that in your calculator. And I'm getting 676. You getting 676? Okay, now if you look back, okay, we can't just do the dot product. We have to take the square root of it at the very end. That'll give us the magnitude. So we're going to take the square root of 676, which is 26. That's our magnitude. Okay, they won't always work out to be nice numbers. Questions for me on number 9? Okay, same thing on number 10. So we're going to do a dot a. Don't get intimidated by the square roots. You're going to be able to put it in your calculator, so you don't have to do this in your head. You're going to be totally fine. So a dot a is 176. If you put that in your calculator, you should get 176. And then we have to take the square root of 176, which is 13.27. I am not going to have you break down radicals and you put them in your calculator and give me the actual. Okay, so you don't have to do all the breaking down of radicals. Go ahead and try 11 and 12 on your own. I'll get you started in writing the vector since it's in linear combination form. Okay, so this vector is just -2, 18. Okay, take it out of linear combination form. So try 11 and 12. Should hit 18.11 for number 11. Okay, there's your answers for 11. Any issues? Get the same answers? Yeah. Again, you can just zoom in your calculator. It doesn't have to be anything big. Okay, questions before we move on? All right, the angle between two vectors is the last part of these notes. This one is not hard. Okay, it's not hard. You just have to use the formula. There's a lot going on in the formula. So we're going to take it kind of slow to start here. Okay. Here is the fill-ins there. Okay, the top, the one with the cosine, that is the formula we're going to be using. Okay, so before we move on, I want to break down the formula. Okay, we are basically finding the angle between two vectors. So when we're given two vectors, we're finding the angle between those vectors. That's what this formula is. So on the very top, okay, this right here is the dot product of the two vectors. This is our dot product. And then this bottom part is the magnitude of each vector separately. Okay, so you're finding the magnitude of the first vector and the magnitude of the second vector. Okay, so those are separately. If you don't want to make those notes, you do not have to. We're going to dive into number 13. I think you're going to be fine with the numerators. I'm just worried about the denominators, but I think we'll be able to get it here. So we're going to first just start by writing the actual formula without any numbers. Okay. So in this case, we're going to do u dot v on top. We have vectors u and v. And then we're going to do the magnitude of u times the magnitude of v. Now let me ask you, do you prefer to find the magnitude this way or with the dot product like we just did on the 4 examples at the top? Do you prefer one over the other? No? Okay. If you can do it however you want. I don't care. For space's sake, I'm going to do it with the square root because it gets a little bit crazy with the others, but you can do it however you want. Okay. Let's go ahead and put in our numbers. So for the dot product on the very top, okay, that's where we do the first one multiplied to the first one and the second, and then we do the second multiplied. So dot product on the top, exactly what we just did the previous examples and what we did yesterday. questions on the numerator. Okay, so then on the bottom, we are going to do the magnitudes of each vector. So if we have u, it's going to be 8 squared plus negative 7 squared. And then for v, negative 7 squared plus negative. Okay, I'm going to do this in the calculator with you because obviously there's a lot going on. So I want to make sure that we do it properly and I kind of show you the best method of putting it in here. Okay, so what I usually do is I do the numerator and the denominator separately. So I'm going to go ahead and put in my numerator. Which is negative 35. So go ahead and write equals, and then have that numerator of negative 35. Then the denominator, I do each of these separately, and it seems kind of crazy, but it can get insane. Oh, you know what? Let's do it this way. Do it without the square root, so that way you get numbers. It's going to get real ugly if we start rounding. Okay, so you have the square root of 113 for the first one. And the square root of 58 for the second one. Okay, and you can multiply 113 and 58. And get 6,554. So what we have is we have cosine theta equals this. It's a lot, once you get it in, it's just simplifying. That's really all it is. Do you guys remember how we find an angle when it looks like this? It's kind of like when we did the tangent. When we put it in our calculator, what do we have to do? Cosine inverse. Oops. We have to do cosine inverse on this. Okay? So you'll press second cosine, and then you'll put your fraction in. Do it with you here. Make sure you're in degree mode. So if you'll notice, I put my negative 35 in parentheses. It's just by habit because sometimes when it's a negative, things will get weird if you don't put it in parentheses. So that's why I do that. Press enter, and our angle is 115.6 degrees. So the angle between our two vectors, which I don't remember what they were, V and W or whatever it was, is 115.6. And we're kind of on the lookout for, do we get 90 degrees? Do we get 180? Because if you look at your notes, if you get 90 degrees, it's perpendicular. The two angles are perpendicular. If you get 0 or 180, they're parallel vectors. Okay, so we're kind of on the lookout for that. It's not a huge deal, but if it happens, we just have to say that they're parallel or perpendicular. Okay, I know that they take a while. A lot of simplifying. Okay, let's hop to number 14. So we're going to write out our formula. We're going to do m dot n. And then on the bottom, magnitude of m times the magnitude of n. Okay, so on top, we'll have 0 times -3, 6 times 5. Okay, and then we do our magnitudes on the bottom. I can show you a faster way to do the bottom. It's going to be a lot of rounding, and I think I want to stay away from that. So we're going to stick with what we had. So on the top, I get 0, so that'd be 30. Again, you can do that in your calculator. That'll just be 9. Square root of 9. And this one should be the square root of 61. So again, when you put in your calculator, don't put in the square root part, just put in the numbers so we don't have to start rounding. And then here, I'm going to go ahead and do my 9 times 61, which is 549. So I'm just kind of breaking it down until I can put it in my calculator, and it looks decently nice. Okay, there's what I'm putting in my calculator. What's up?
For the square roots on the bottom, wouldn't you put a and b, not the two a's?
Did I do something? Did I do it wrong? Maybe I did. I might have. We're all struggling, right? It's Friday. Okay. Thank you for catching that. Okay, so we have, should be, yes, 0 and 6, which I can't see it because I scrolled up. So right here, you're doing the 0 and the 6. So 0 squared plus 6. And then we did the -3 and 5. So this will be square root of 36. Okay, and 36 times 34 is 1224. All right, so inverse cosine. You should get 30 point, we'll just round it to 31 degrees. It's like 30.96. Okay, so on 15, you can rewrite the vectors if you need to. Try to get the setup. You don't need to start any simplifying. Try to at least just get the setup here. Okay? You can write this guy if you think it's going to help you. Okay, but get the setup. I'll help you with breaking it down. We'll still do that together. Okay, but try to just get the setup on your own. And then we'll come together. be your setup. Go ahead and check it when you get it done. Any questions or issues on the setup? Okay. So on top, I'm getting 12. Yep, 12. And on the bottom, we get the square root of 85. And the square root of 117. You multiply 85 by 117. You should get 9945. Okay, any questions on that second row at all? Any issues? So here's where we do our inverse cosine. Should get 83.09 degrees. Remember, you're doing inverse cosine, so second cosine. Put in your fraction. Questions, issues? Okay, give number 16 a shot on your own. Hint, you should get either 0, 180, or 90. Okay, so one of those three numbers should be your answer for number 16. That's my hint. Okay, so give it number 16 a shot here. Give it a couple minutes, and then we'll do it on the board. Okay, we should get to this point. Any issues or errors on getting to that point, you're not really sure why. Okay, now, does anybody know the square root of 225? Tap the red. 15. Okay? So you do not, by all means, you do not have to simplify this. Okay, you can just do it like normal, like we have been, and put it in your calculator, but this is actually just -1. So you can actually just do inverse cosine of -1, and you should get 180. You do not have to, though. If you just do this, and you do the inverse cosine of this fraction, you should still get 180. Okay, so in this case, is it parallel or perpendicular? Parallel. Yeah. Parallel. Because parallel is 0 over 180. Perpendicular. Am I doing that right? Yeah, perpendicular is 90. Yep. Okay. That's all for today. We